2.2.7 Config as Code, Ansible and Helm and why it all matters. In earlier chapters, we built an important foundation. Code now travels through pipelines automatically. Artifacts are reproducible. Tests guard behavior before anyone gets hurt. But there is still a quiet problem that almost every team eventually runs into. The software behaves one way in development, another way in staging. And in production, sometimes it behaves like a completely different creature. Nothing is physically broken. It just feels unpredictable. Very often, that unpredictability doesn't come from code. It comes from configuration. Someone tuned a timeout on one server. Someone changed a flag temporarily. Someone adjusted logging just to debug something and forgot to undo it. Over months, environments drift apart. And nobody can quite explain why the same system acts differently in different places. That's the moment teams learn a painful truth. If configuration lives in people's heads or on random servers, it will eventually betray you. So the industry did something clever. It took configuration out of hands and out of memory and put it into code. That idea is called config as code. And it changes everything. Before we talk about specific tools, we first need to separate two ideas that people often mix together: infrastructure and configuration. Earlier, when we spoke about infrastructure as code, we talked about tools like Terraform. Terraform creates things: servers, networks, databases, clusters. Config as code doesn't create infrastructure. It teaches infrastructure how to behave. Think of it like this: Terraform builds the house. Config as code decides where the furniture goes, how the lights behave, and what rules the household follows. Two complementary layers. One builds, one configures. Both must be reliable. Once that difference is clear, we can look at one of the tools that changed how teams configure servers in the real world: Ansible. Imagine a company that manages hundreds of servers. Before config as code, an admin might log into one machine, change a config file here, install a package there, restart something manually. Another admin logs into another server and does it slightly differently, and without realizing it, they just created two versions of production. Ansible solves that problem in a very simple way. Instead of saying, "Go to this server and run these commands," you declare, "This server should look like this." Ansible looks at reality, compares it to the description, and gently moves the system toward the desired state. If a package is missing, it installs it. If a configuration file is wrong, it fixes it. If something is already correct, it leaves it alone. And because the configuration is written as code, stored in Git, reviewed, versioned, and approved, any change becomes traceable. No quiet edits, no mystery behavior, no guessing who changed what. And if something goes wrong, you simply revert the change, not on the server, in Git. And Ansible brings everything back to the safe state. That moment is when engineers realize configuration doesn't have to be emotional anymore. And inside Kubernetes, the same idea shows up again, only this time it has a different name, and it's called Helm. Now imagine the same story, but inside Kubernetes. Kubernetes applications are described through YAML files that can become complex fast. One version for development, another for staging, a slightly different one for production. Copy-paste, adjust values, hope nothing breaks. Helm solves that chaos, and instead of writing separate files for every environment, you define a single blueprint, called a chart, and then provide values for each environment. The application itself stays the same, only the parameters adapt. So development might use one database endpoint, staging uses another, production uses the final one, all driven from structured values, not hand-edited files. The pipeline promotes that same chart forward, just with appropriate configuration for each phase. Consistency without duplication. But the real magic of config as code appears when something called drift shows up. And every serious system eventually experiences it. One of the most powerful effects of config as code is something people rarely talk about at first: drift detection. When environments are configured manually, nobody knows when reality stops matching documentation. With config as code, the pipeline can constantly compare what the system is supposed to look like versus what it actually looks like right now. If someone changes something by hand, the system detects the drift. It can warn. It can reapply the correct state. In strict setups, it can even refuse to deploy until drift is resolved. The environment stops being mysterious. It becomes measurable. Another place where config as code quietly shines is security, not as an afterthought, but as something built into the process itself. Configuration mistakes sometimes create security problems, over-permissive roles, open network ports, sensitive data copied into logs. With config as code, those mistakes become visible as code reviews before they become headlines. Secrets aren't committed directly. They are referenced safely encrypted, injected only when needed. Many companies even run automated policy checks on configuration before pipelines approve it. Security stops being an afterthought. It becomes part of the story. And there's a benefit most teams don't think about until the day they desperately need it: compliance and auditing. Nobody gets excited about audits. But config as code quietly solves one of the biggest headaches in regulated industries. Every change has a pull request. Every pull request has a reviewer. Every deployment has a recorded commit. If an auditor asks, "When did you change this?" the engineering team doesn't guess. They open the history and show the decision in black and white. No arguing, no speculation, just evidence. At this point, it's also important to clear up a common misunderstanding about config as code: what it is and what it is not. Some teams hear config as code and think, okay, so everything is just big YALM files now. That's not the goal. The goal is not clever templates. The goal is not complicated scripts. The goal is clarity. Declarative systems like Ansible and Helm work because they describe outcomes, not step-by-step instructions. Readable beats clever. Predictable beats heroic. When configuration becomes code, something interesting happens in the CI/CD pipeline. Configuration starts following the exact same rules as software. Once config as code exists, pipelines take over. A developer proposes a configuration change. It goes into Git. Teammates review it. Policies may require two approvals. The pipeline applies the change the same way every time. No special cases. No late-night terminal sessions on production machines. And if the change creates an issue, rollback is not drama. It is simply revert the commit. The system aligns itself. Over time, that way of working changes the team's mindset, sometimes without them even noticing. At some point, a team that truly adopts config as code notices something subtle. Nobody asks anymore, "Who changed production?" They ask, "Which commit changed production?" And instead of fear, there is curiosity. Instead of firefighting, there is learning. Configuration becomes part of engineering discipline, not something improvised under pressure. And if someone ever asks you about this in an interview, there's a simple way to explain it so they immediately understand. If someone in an interview asks, "What problem does config as code actually solve?" a strong answer sounds grounded and simple. It makes configuration predictable, reviewable, and repeatable. Instead of editing servers directly, we declare how systems should behave. Tools like Ansible and Helm enforce that state, pipelines apply it, and if something drifts, we detect and correct it. That gives us consistency across environments, safer rollbacks, and full history of every change. Not hype, just clarity. With that foundation in place, the next natural question becomes, how do we actually release changes safely without disturbing users? Now we have something powerful. Code is tested automatically. Artifacts are reproducible. Configuration behaves like disciplined engineering rather than improvisation. There is still one final question. If we can declare environments and declare configuration, how do we release those changes gradually, carefully, without disrupting users? That question brings us straight into the world of deployment strategies. Rolling releases, blue-green, and canary deployments. And that's our next chapter.